let's take a look at our warm-ups. I know it says lesson 1.3, but we're doing it after 1.5. I just believe the order in the textbook's a little off for the way we teach the lessons here. So I find it is a better flow if we go back and do 1.3 after we've done all the other lessons in between 1.4 and 1.5. So let's take a look at some of these warm-ups. 1, find the inverse function for each of the following. So remember, for A, when you're given a set of ordered points, okay, normally you have X and Y. Don't forget to switch them to Y and X. Okay, so they switch order. Okay, so again, you have 2 and -3. It becomes -3 and 2. Okay, so you flip the order and the sign stays with the numerical value. Okay. So again, the inverse function has the opposites for the data points. You just switch X and Y. When you're given a function, ladies and gentlemen, with an equation, simply I rewrite the function from function notation to Y equals, then we switch X and Y, and it's a matter of rearranging and solving for Y. And then lastly, don't forget that it's not really Y, it's actually the inverse of that function that gives you that solution. Taking a look at C, the same case. I've rearranged this. I replace Y with X. I then solve for Y. And again, function notation, the inverse of the function is -5x plus 7. Okay. Number 2, identify the domain and range for each function. Again, if the equation is given, you have to decide what it looks like as a visual graph. So looking at that, we've decided it's linear. It's going to form Y equals mx plus b, so we have no restrictions. So again, domain is x belongs to a set of real numbers, and the range is, you can either have Y belongs to a set of real numbers or f at x belongs to a set of real numbers. I will accept either. B is a tricky one. Taking a look at this expression, it's quadratic, but it's in standard form. Standard form does not give us the maximum value we need in order to do our restrictions. So again, you've got to switch standard form to vertex form, and remember to do that, you need to complete the square. So to complete the square, step 1 is you factor A out of the first 2 terms. Step 2, in the margin, you take the b value, you divide by 2, and you square it. Next, you take that value, in this case it's 1, and you're going to add 1 and subtract 1. Next, you realize that you only need the first 3 terms to complete the perfect square. So likewise, this -1 out here at the end, it needs to come out of the bracket, but in order to take it out, you've got to remember to multiply it by the 2 in front. So taking a look at your next line, you've got the A out front, you've got your perfect square, and then you've got some constants that you need to collect like terms. Then you realize that completing the square, you have now a binomial squared, which gives you, ladies and gentlemen, your vertex. And your vertex is -1 and -7. A is positive, so the direction of opening is up. So plotting that on the graph, you go -1, -7. And since A is positive, it opens up, so this is a minimum. So when you go to state your restrictions, the domain is such that x belongs to a set of real numbers, and y, or the range, belongs to the set of real numbers such that y has to be greater than or equal to 7. You could have also replaced that instead of y, you could have used f at x as well, is the same solution. Okay, last one, C. This is a square root function. Okay, so again, you're underneath the square root cannot equal 0, so you represent that as being greater than or equal to 0 because it can't be negative. Okay, I'm not sure if I said that right, but remember the expression underneath cannot be negative, so it's got to be greater than or equal to 0, and then you solve for x. So again, there is a restriction on your x. X has to be greater than or equal to 6, and for y, this function, which we're going to learn a little later on in this lesson, always is going to be greater than or equal to 0 when we take a look at square roots. This ends our warm-ups. Let's take a look at the lesson. Very important for this lesson today that you use the handout that I provided. It's going to be a chart. And for each chart, ladies and gentlemen, you're going to be filling in the key pieces of information. This will be one of your great study sheets that you should use to review for when it's time for the unit test. So today we will use the handout. Okay, so I should have given you that in class. And if you need to make reference, the textbook is on page 26, 27, but we're just going to be using this smartboard. If you have a graphing calculator, it will also help you, or go to my website under Useful Math Tools, and you'll see a calculator there. Just change it where it says scientific to graphing, and you could graph these. It would be great practice for you to use these in class, the graphing calculators, to help you. The first parent function, so look on your first chart, ladies and gentlemen. It's a linear function. So the parent function, the most easiest form of a linear equation is y equals x. So fill that under the column for that. Okay? Then what we're going to do, guys, is plug that in the graphing calculator. So you go to y equals, and then you press x, which is your x, t, theta, n button. Okay? And when you graph this with a graphing calculator, you get this graph. Okay? If you have the graphing calculator simulator, you can press second and graph, and then the table will come up, and you can get your table of values from there. Otherwise, you can pick values from the left and right side for x, for your independent, sub them into our equation here, and get y. Okay? All right? So again, you've got a linear line. In this case, the parent function is the easiest, which is your diagonal, y equals x. And for your domain, put that in that column under domain. It is x belongs to a set of real numbers. The range is y belongs to a set of real numbers. Put that in your range column. And here are some notes to add to your chart. Okay? For your notes, it's a straight line diagonal. It goes through the origin. It has a slope of 1, and it's in quadrant Q1 and Q3. Just remember, if you've got a Cartesian plane, this is Q1, this is Q2, this is Q3, and this is Q4. We'll be making reference to that in your other parent functions as well. All right? So now we're going to go to our next parent function. Apologize for that bell. For our next parent function, it's quadratic function. Okay? Again, the most basic quadratic, ladies and gentlemen, or most basic parabola is y equals x squared. If you remember back in the grade 10, that is where we did all our transformations from. Okay? We either shifted left, right, up, down from there. So again, you can either use a graphing calculator, graph this up, get this graph, and then press second and graph, and you'll get this table. Or you can just sub values into the equation. Okay? And again, you're going to notice for the domain, x belongs to a set of real numbers. There's no restriction there. And for the range is going to be that y has to be greater than or equal to 0 for the parent function. If we shift this up or down, or have a minimum, if we have a minimum or a maximum value greater than 0,
Carrie Brown,
sorry about that, guys.
Austin Fair,
Let me pause.
and Nick McElroy, please.
We're almost done. Sorry about that, guys. Let me just say, you have, for your restriction for your range, it's going to depend on your max.
Ms. Carter, please call Park 147. Ms. Carter, call Park 147 as well. If you had a spare period 1 and you ordered
Sorry, I'm going to pause it,
please
guys.
come.
Sorry about that, guys. I'm just trying to do this in class, and if PA is going.
Thank you. The following students, please go to the main office. Amber.
Sorry for that interruption, guys. Hopefully you won't have any
With
more.
Naomi Iliantro,
Sorry.
please come to the office.
Okay. Sorry, guys. Okay, so back to your range, guys. It depends on your minimum and maximum value of your
Ms. Carter, call 147, please. Ms. Carter, call Park 1.
Okay, folks, we'll try this again. So again, the range is going to have a restriction wherever your min or maximum value is. It depends on your direction of opening And if there's a min or max, it's going to be either greater than or equal to or less than or equal to. Notes on the last column, guys, the direction of opening for your parent function is up, the vertex is 0, 0, and your step pattern is 1, 3, 5. And remember, it's A times 1, 3, 5. However, this stopped working on me. Just a second. So it's A times 1. A times 1, 3, 5. Let's see if this is still recording. So again, guys, it's A times, please work. Let me put it down, there's something wrong with the smartboard. A times 1, 3, 5, but in this case, A is 1, so that's why the step pattern for this is just 1, 3, 5, and it's in quadrants 1 and 2. Okay, let's go to the next one on our chart. Okay, the third one is our square root function. We've been talking a little bit about this in class. It looks like a half of a parabola turned sideways. Okay, so taking a look at this parent function, it's y equals the square root of x. When you go to plug it in your calculator, this is where you have to be careful of what values you choose. You want to pick values, ladies and gentlemen, that go into a square root evenly. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Could we put in -1? No, because you can't take a negative value. That's why it doesn't appear down here, guys. That's why it's empty down here. You can't input a negative value, okay, or over here, okay? All right. Taking a look, ladies and gentlemen, so you plug that into your graphing calculator, get a nice graph. Again, you can go to second graph, which is your table. You can find the values of that as well. Looking at our parent function here, the square root, we notice that x is going to be greater than or equal to 0, okay? And that y has to be greater than or equal to 0 for its parent function. All right? Notes to write down, it's half of a parabola that opens to the right. Our vertex or starting point in this case is 0, 0, and it's only in quadrant 1. Okay, next one, ladies and gentlemen, is our reciprocal. I like this one. It's the funniest looking one, okay? What we have here, folks, is y equals 1 over x for our parent function. When we try to graph this, -2 will give us a value -1. If we plug in 0 into this, 1 divided by 0 will give you an error in the calculator, okay? The reason that will give you an error in the calculator is because you will find there's an asymptote there, okay? So for a reciprocal function, plug that in your graphing calculator, and you should hopefully get this graph right here. This graph, ladies and gentlemen, has key points of 1, 1, and -1, -1. And then from there, because there's asymptotes both up and to the side or down and to the side, it has a curve that approaches the asymptotes. Remember, the asymptotes, which are these red dotted lines, are a line that a function approaches closer and closer to, but will never cross or touch. You could check this out by going to the table, i.e. second graph, and scrolling all the way down. And notice your fractions will get smaller and smaller and smaller for y, or larger and larger and larger for y, but they'll never get to 0. All right? Okay? Taking a look at domain and range, because there's asymptotes, those asymptotes are our restrictions. So the domain is such that x cannot be equal to 0, and our range is such that y cannot be equal to 0. Okay? There's a new term for this. It's called a hyperbola. Okay? And its x and y axes are the asymptotes. And it is on Q1 and Q3. So again, fill that in. And our last last function for our chart is the absolute value function. Again, we take a look, y equals the absolute value of x. What does that mean? If you have a negative number, you put it in and it's going to just become its positive number. So graph it into your graphing calculator. If you get a straight V, okay, similar to the parabola, but it's straight, okay? And remember, your domain It's x belongs to a set of real numbers, and your range is y is greater than or equal to 0 for the parent function. Okay? And our notes are that we have two lines on upward diagonals. Our vertex, our starting point is 0, 0. Y-axis is the line of symmetry, and we have Q1 and Q2 being where these functions exist. Okay? Now, if you can, ladies and gentlemen, use your graphing calculator at home and try to see if you can find these transformations, because this is what we're going to be dealing with in the next little while. So use a graphing calculator from our website to actually draw each of these parent functions. Okay? Just remember when you're doing the square root, you're going to have to use x hat 0.5, and for absolute value, you're going to need to go in and write ABS and X to get your absolute value. Okay? Try to color code them, guys, if you can, and produce nice graphs so you can see what's happening in each case. All right? Okay. So again, the first one is your parent function is your quadratic. B, your parent function is your square root. C, your parent function is your reciprocal, and D, your parent function is your absolute value. I will post the solutions to this in tomorrow's or next day's lesson. Thank you and good luck. See me if you need help.